Hey everybody, welcome to Modular Community Livestream. I'm your host Shashank and my co-host Jack. Hey Jack, how you doing, man?
Hey, good. How you going?
I think this is going to be one of my favorite live streams. You know why? We
Why's
have
that?
we have two amazing guests today. For the first time, we have members from the Mojo community here, Aiden and Elliot. We'll quickly do some introductions and get started. So while you join in, please go ahead and say hello to everyone and let us know where you're joining from. And if you're joining from somewhere where it's late in night, thank you for staying awake and uh, joining us today. We're really excited. We have a lot of new things to show you today. And the theme for today's live stream is, of course, Mac, Mojo on Mac. So I'm Shashank. I'm a developer advocate at Modular. And Jack, you want to go next?
Hey, I'm Jeff. I work on Mojo at Modular.
Awesome. Welcome, Jeff. And who wants to go next?
Hey, yeah, I'm Jack. I'm a developer advocate at Modular.
Awesome. And our first superstar guest, Aiden.
Hey everyone, I'm Aiden, joining you from London.
Awesome. Aiden, as you may know, is the creator of the Llama.mojo project. We'll hear a lot more about that in the live stream, so stay tuned. And next, Elliot.
Hey guys, so my name's Elliot. I'm currently in Edmonton, Alberta. I made the Intro to Mojo course on Free Code Camp. Right now I'm a first year CS student and I just kind of make cool tutorials. I do some AI research on the side and just kind of enjoy these new technologies. So I'm looking forward to this.
Awesome. Welcome, Elliot. And for those of you who haven't checked it out, you should. Elliot is our second superstar guest today. This is the course he was talking about. It's an awesome course. I highly recommend you check it out. Not right now. Let's go through the live stream, and we have lots to show you after the live stream if you want to. He has close to 100,000 views, and we know you will. It's 99,000 now. We know you will help us cross 100,000 today. Awesome. So who else do we have? Abdul.
Yeah, hi, my name is Abdul. I come from Seattle, Washington, and I lead the high performance team here at Modular.
Awesome. Abdul is our regular guest on the show. And between all of us, we have several demos today. We have interesting presentations by both Elliot and Aiden and some recent changes in Mojo that Jeff and Abdul will share. So lots to talk about today. And I see folks joining in from all around the world, Norway, Seattle, Washington too. Awesome. And India, so nice to have you all here. Egypt, that's awesome. So nice to have you all here. And again, once again, thank you for joining in at an odd time. We appreciate you joining us. So because we have a packed agenda, let's quickly get started. As I mentioned, the focus of today's presentation is Mojo on Mac. And if you haven't already checked out, Mac is now, Mojo is available on Mac. If you head over to the product page, hit download, you will see that we've updated instructions for Mojo on Mac, specifically Apple Silicon, which is M1 and M2 Macs. We did have support for Intel Macs via Docker container, Ubuntu Docker containers, but we have native support for Mac Apple Silicon. We also did a blog post. Let me pull up the let's go back to the homepage and pull up the blog post. This was the most popular feature that you all requested, and we are so happy to have support. We had over about 250 upvotes, and this shows that we are listening to you. If you have questions, feature requests, please share them on GitHub and upvote them. That is how it helps us prioritize features. So today we want to talk about Mac support and some cool performance benefits that you can get with Mojo and Mac. And the instructions all here. I don't plan to go through the instructions and setup. It's fairly straightforward. What we'll do instead is show you some performance benefits. With that, I will hand over to Jack, who will talk about some common setup things with Python integration and also performance benefits. So, Jack, all yours.
Thanks, Shashank. Yeah, so I'm just going to be going over running the matmul.mojo. So I got my cores up here that you can see on the right, and it's just running through it. And you'll see I'll get a big spike here showing that all the cores are activated on my MacBook. So this is going a fair bit slower just because I got all this other stuff running, but it gets up to about sort of 90,000 faster than Python and significantly faster than NumPy as well. So make sure to check that out. You can compare NumPy to Mojo and see how much faster it is. And then the other quick things I just wanted to go through were some like common sort of issues that people are having installing Mojo on their computer. So the first one is just homebrew install location, and sometimes it will say ARM64 architecture is required. So to fix that, I got links in the video description, but you can go to this page to reinstall homebrew, and that seems to be fixing it for most people. And then the other one is just for if you have any Python errors or you're getting an error saying that NumPy isn't installed correctly. There's a link in the video description to this, and it just shows you how to install Miniconda and then use that environment. So that'll fix most problems for you. And then just the last thing I wanted to show was this awesome Mojo repo. So there's a lot of really cool stuff in here. If you scroll through it, my favorite things at the moment are Infermo, which is like AutoGrad in Mojo, and there's Grady.mojo, which is gradient descent in Mojo here. And there's a new cool one that just got added this morning, FFI, and it has links to show you how to call C libraries from Mojo and also call Mojo functions from C. I haven't got a chance to play with this, but yeah, check it out. And that's it. Thanks, Shashank.
Yeah, that is awesome. And Jack, you just glossed over it, but there was Aiden's project to Llama, and there's so many other projects there. And this is all you, right? This is all you community members using Mojo and setting, implementing these. And the interesting thing is now all of them will run on Mac. So feel free to go check it out and let us know what your experience is like using Mojo on Mac, and of course GitHub for feature requests and bug reports and all that. Okay, so we have a packed agenda. So let's start with our guest presentations today. My favorite, one of my favorite projects is the Llama.mojo. I know many of you have tried it out. We've done demos of these in the past. We have Aiden, who created Llama.mojo, and Aiden, I'll hand it off to you. Let us know what Llama.mojo is and your journey to implementing it. Before we go there, I'll also mention that we have an awesome blog post from Aiden that we published last week. So if you head over to modular.com/blog, here's a community spotlight blog post we did by Aiden, where Aiden walks through his journey discovering Mojo and building Llama2.mojo. So I'll pause here and hand it off to Aiden.
Yeah, hi everyone. So I'm Aiden. So my primary focus areas are platform engineering and building performant ML systems. And in my spare time, I just crafting some open source projects. And lately, I'm really into Mojo, where I hope I made something worth sharing with the community. And it's a pleasure to be here. Thank you guys for inviting me into this live stream. So I'm just going to provide some brief overview of the benchmarks I published this week. So do you see my screen, guys?
Looks good, Aiden.
Okay.
Really excited.
So yeah, I will give some context what's going on here. So as many folks know, there is an open source project created by Andrej Karpathy. This is Llama 2 model inference implementation in a single plain file of C. Right after it was released, many folks in the community ported it into multiple platforms and programming languages. And I created one of this variation on plain Mojo early in September. And that got really, really great traction on GitHub. And now my goal was to compare how our Mojo implementation performed on Mac M1. And along the way, I included into this benchmarking 11 other implementations on 7 different languages. So Basically, we have C++, then Mojo, then Zig, a few variations of Zig, C, the original repository from Andrei Karpathy. And also, I was able to build and run the famous project from Georgy Garganov, the Llama CPP. I took the 3 baby Llama models with 15 million parameters, 42 million parameters, and 110 million parameters, and built test environment to execute them in 2 modes, like single thread and parallel, in 30 rounds each. So this approach, I believe, must be the fair for comparison purposes. So let's check this out. The full report is here, and the main outcome, honestly, for me, is the most shocking part, is that Mojo is not only outperforms the C original implementation, but it also performed right up with the Llama CPP. And for people who are aware of how Llama CPP implemented, and they probably know that the amount of effort the community put into the solution, like squeezing out every single possible inch of hardware performance, and it has literally a ton of optimizations under the hood, and that's why the results I got are really impressive. So I still believe that there are multiple opportunities to speed up the Mojo implementation further, like use tiles, aftertunes, benchmark Mojo utils, and all that. That's something I still need to discover how to deal with. Also, I need to discover some behavior of, for example, Zig. In my benchmarks, Zig was showing, I think 2 implementations of Zig was showing the similar performance in multi-threaded and single-threaded mode. Like this is the multi-threaded mode, storage 15M, storage 42M, and storage 110. And this is single-threaded mode, and Zig also, it makes an impression that Zig is outperforming everything. But I have some insight about this. Probably, most likely, it's spinning up extra threads in the background during the single-threaded runs. So because that would be explained why it didn't slow down. However, it gives some hints to the language-specific forks and maintainers to deal with the results of this report and further investigate how it's implemented internally. And I definitely recommend everyone who's interested in Mojo check out the Llama to Mojo repository and the report. I tried to optimize all the benchmarks for max performance, but I think there are still some opportunities to refine the tools, optimize the compiler options, or implement some other tweaks. And I consider this report as a first iteration, and probably community, Mojo community, Python community, other language communities can contribute into this report. I'm going to put up everything on the GitHub so that everyone can check out and reproduce all the results on their local machines, and we can try to optimize our solutions further. So yeah, I think that's it from my side. I'm sure there are people who are willing to contribute into this, and I really appreciate any contributions and discussions around the report in general.
Awesome, Aiden. Thank you. And for everyone who's on the live stream watching, this is a Q&A live stream. So please feel free to ask questions. We have so many experts here, folks who built these amazing projects, but also engineers like Abdul and Jeff. Please feel free to ask questions about Mojo on Mac, features, capabilities, how to get speed up, whatever it is. Feel free to post in your questions. And I just want to share that the blog post that we published on this, I have a screenshot here on running Mojo, Llama 2.mojo, and you can see the speed up here. This is running on Mac, so this is running on my M1 Mac and M2 Mac, and you should try it out too. Git clone the repository, try it out, and share your feedback and also ask us questions. Okay. There are a couple of questions coming in. Maybe we'll take a couple before we move on. So here's a question that's about multi-processing. I'd like to know how Mojo handles multi-processing, especially given challenges in standard Python. Is that complete enough of a question? Anyone wants to take it? Jack, Abdul, Jeff?
Well,
anyone?
I can try to answer part of the question. So Python relies on multiprocessing to do parallelism because the Python interpreter is single-threaded. So the way Python does, parallel computations, it spawns other instances of the Python interpreter and runs them as separate processes on the operating system. And this works, but obviously communicating across different interpreter instances can be tricky from an API perspective, and it is not as performant. So in Mojo, we don't need to rely on multiprocessing to do parallel computations. You can just have multiple threads in the same process. So yes, you can do multiprocessing, as in multiple Mojo processes can communicate with each other, but we don't have stuff like that built into the standard library yet. The way to do parallel computations is just to spawn multiple threads.
Cool.
Yeah, I would just add there's a parallelize function that will give you multiple threads, so it's built into the language.
Yeah, actually, the demo that Jack showed earlier with Matmul, it's fairly simply implemented because of the parallelize function, right? It's if I may, I'll just quickly show. Okay, we'll come to the demos later. We'll do a couple more questions before we get there. So here's another question. What is the future of, I guess it's forward looking, but packaging and tooling for Mojo look like? Anyone wants to take that? Like packages in Mojo?
So you can build packages, but there is no there is no system for sharing and distributing packages, as well as integrating them with build systems like CMake or Bazel. So that's something that we're working on now. And in the future, there'll be some better ways to define a Mojo project and, share packages around between people's computers. Think about how Go has built-in support for, or sort of built-in support for packaging and fetching code from other, from web URLs and stuff. So we'll have something like that, and hopefully in the future.
Awesome. I wanted to share sort of the API that Abdul mentioned. There's a parallelize function where you can. It's pretty simple to use, right? You specify the function that you want to parallelize, and you can specify number of cores or number of things that you want to parallelize over, and it'll do it for you. All right, we'll also feel free to check out the Matmul example, Mandelbrot example, a couple of examples in the GitHub repository for Mojo, where you can see these reference implementations using vectorization and parallelization. And we'll spend a little more time on that later in the presentation. Okay, a couple more questions and we'll head over to Elliot. Elliot has an awesome topic presentation where he's going to be talking about memory on Mojo. All right. There are, let's see. There's a question on, so many questions. Thank you for all your questions. Is Mojo able to take advantage of MGPUs today? I guess the Apple Silicon GPUs. Anyone want to share any thoughts?
Not right now, no. But there's one thing that Mojo allows you to do is you can plug in and use any MLIR function. You can also use external C functions from within Mojo. So technically you could do that right now, but it's not in the standard library today.
Awesome. Thanks, Abdul. There are a couple of questions which are about installation and people running into a couple of issues. The only thing I will say is please head over to our Discord. There are plenty of resources there. First, check out the descriptions. Jack has put in a couple of links. And secondly, head over to Discord, join our community. People are very friendly, helpful. There's community members and also Mojo and Modular engineers there. You'll get the help you need. Head over to Discord, join Discord, and ask your questions there if you're running into any issues. So here's an interesting question, actually, about packaging. Where can I put the Mojo package files so I can import them from anywhere in my system?
I don't believe we have like an environment variable include path that other languages tend to have. And so for now, you have to specify -i, although the files in the current directory are always automatically included. Please file a feature request if you want one.
Okay, there is one other place you can do this, which is in the modular CFG file. So you can put the path to your location in the modular, what's it called? Import path. So in your home directory .modular/modular pk package pkg file, there's import path, and you can actually. So I ran into this same question, and you can add it there, and then you'll be able to import it in your projects. I'll quickly show you here. There is modular under a modular CFG file. There's import path, so you can provide comma separated values for packages that locations that you want. All right, we'll take one more question and head over to the next topic. So this is how about async? How does it work? I guess this is related to the parallelization question.
So Mojo has async await support. It's similar to Python, but it is more like the traditional async await parallel programming paradigm in programming languages. So async functions on their own don't automatically run on a thread. And so you have to create an async function, and then with a work pool, so there's a work pool type, you can launch the async functions as a task. So it's quite similar to how async IO works in Python.
Awesome. Thanks, Jeff. Okay, let's do the second topic, and there are tons of more questions and some very interesting questions that we want to get to. Let's head over to our next topic. Elliot, you're up next. I know you have an interesting demo to share, something that you've discussed and shared in your course, and I think it's an interesting topic because it's not something that I deal with on a day-to-day basis, and Mojo has some very cool capabilities for memory management and all that you may not be familiar with if you're a Python user. So take it away, Elliot.
Yeah, absolutely. Thanks for having me, guys. So in my course, you should totally check it out. But I cover right now. I'm going to cover a topic that isn't super hyped about and everything. It's memory and function parameters. So a lot of what you'll see right now is, in Aiden's case, he built an amazing project, Llama 2 Mojo, and you have the engineers working on other things, and marketing is great. But at the same time, I think it's also important that we understand a little bit what's going on the memory side. And so that's what this lesson is going to be about. So if I just present my screen here, I'm going to pop over to VS Code. So essentially what this is just, like I said before, function parameters in memory. So we have in-out, we have borrowed, and we have owned. So I'm going to go over these a little bit in depth, just one by one. So first of all, we have this in-out. Well, what the heck does in-out mean? In-out is pretty much you're just passing, you're essentially passing values into it, and they're explicitly mutable because we set them to var. If we were to set them to let, we'll see that we get an invalid call. Argument must be mutable. So let is immutable or constant, and then var is variable, hence the word var. And so all this does is we simply call add nums with these two function parameters, and we get a return value. So if I go ahead and run this script here, so we go Mojo, we'll see that we get the first one here, add nums. So we're just returning the two values added together. This happens to be 5, and then we can also print each of the values separately. So that means these values are still accounted for, and we can still see them after this function add nums is run. So that's a little background on in-out. Now, if we jump down to borrowed here, borrowed is an interesting one. So with borrowed, you're essentially calling a function and the function is borrowing them. So imagine, for example, I were to take your, if I were to take your Intro to Mojo textbook and I just want to use it for information, right? I'm obviously not going to steal it and just take it for myself because that would be rude. So I'm just going to borrow the textbook for the information and then I'm going to give it back. So that's essentially what borrowed is. We're just using some of these values. We're doing some computations with them. In this case, summing. We're summing these two values together and then returning it. But we're not actually holding them or using them for our own. We're not changing them. We're not ripping pages out of the textbook type of thing. So that's what borrowed is. And if I go ahead and actually just run here, you'll see the same, essentially the same values we got before. But if I were to say change A to, well, A is 4 here. So if I change it to like 3 and then I change B to like 2, see that we get errors here, must be mutable. So I could change these to bar and we'll see still it must be mutable. Essentially, we're just borrowing them. We can't change the values. So that's what the borrowed keyword means. And so last but not least, let's jump down to owned. And owned is an interesting one. So with owned, when you pass an owned to this add nums function, essentially what's happening is this function now owns these variables. So it has it to itself, and this function no longer does. So let me just help you guys visualize this. So if we run this, I'll just extend the terminal out here. Yeah, so essentially we're not allowed to do that because yeah, so we get we get an uninitialized value error because the own function essentially takes the variables for itself, leaving the previous initialized variables from this function out of scope from the own function. So it's essentially snatching them away. So you have this add nums and it's going to be essentially snatching these values for itself, and this main function no longer has them because this one owns it. And then you might ask, well, we make it immutable here. We make it explicitly immutable. Well, own still overrides that, so you actually end up still being able to mutate these variables. And so yeah, that's some background on in-out, borrowed, and owned.
That's awesome. Thanks, Elliot. And I was wondering, like many of you are probably, what is in-out, right? Why is it called in-out? And if you take a look at the programming manual, actually, it says that the argument inside the function are visible outside the function. That's in from inside and out from outside, in-out. So that's like a cool Mojo thing. Yeah, it's pretty cool when you want to pass by reference, make some changes that's reflected outside, right? So thanks, Elliot. I think that's pretty cool, because if you're building, I think for many of you, and like Aiden, if you're building projects and packages, it's kind of important to know how to use some of these things to be efficient, and they matter for performance and all that. So with that, I just want to maybe pause and ask if Abdul and Jeff wants to add any color to that, any like nuances or any tips and tricks on memory stuff.
Yeah, so I mean, memory is sometimes overlooked. It becomes super important when you have very large projects where you kind of say, okay, I'm going to pass ownership to you, and now I'm no longer able to use it. So it's what Elliot was showing, you might be able to see like the code side by side and say, oh, I could figure that out. But as you go to like hundreds of thousands of lines of code, multiple files, it becomes hard. It's also a matter of correctness. So if I open a file, now I own the file, and if I pass it, I have to say either I'm borrowing that file or I'm passing it as an ownership, so moving the file to another function so that the function knows like, okay, I need to close it after I'm done. Otherwise, you get memory leaks, you get a bunch of things. And one thing that we've done is in Mojo is we looked at a lot of different languages that try and do ownerships, and we just took the best ideas and made very great defaults so that folks don't have to like learn very complicated syntax or terms to actually just get started.
Awesome. Thanks, Abdul. Yeah, it's I think it's new for a lot of folks coming in from dynamically typed world. Like you don't have to deal with these, but at the same time, it's a lot. At least my experience, a lot easier than languages like C. I think Mojo kind of gives you the best of both worlds, if you will.
Well, I would say dynamic languages, you still have to deal with them. Like if I open a file in Python and I pass it around,
Right.
I still have to know, like, okay, am I the person that's closing it, or is it closed somewhere else? And that creates like a lot of bugs. It creates a lot of like weird thing. Like if I close it, I mark it, and then I cannot close it again, and these weird things. So it's hard to reason about all of that. So it occurs. It occurs. Even though it's not memory, it's like a ownership lifetimes.
Right.
Something that occurs in many, in even dynamic languages, even scripting languages. I open a socket and now I have to figure out when do I close it.
Right. Yeah. Some languages they allow you to make mistakes, but it's on you to not make those mistakes. But if you're strict with languages that are a little more stricter, then you're pretty much doesn't allow you to make mistakes. So
right. And mistakes that are caught, like what Elliot was showing at, like, as I'm developing, as I'm in the editors showing squiggly lines, it's easy to spot these mistakes rather than, when I run it or 5 years down the line, if it goes into some code path, I figure out that mistake. It's very hard to debug those things.
Yeah, awesome. Okay, that was cool actually, because as someone who spent a lot more time in Python, like I don't think about these things, but it's important, right? It's important to think about these things. We'll do a couple of questions. There are a couple of questions that came in about Python and Python interop. So broadly answering, yes, you can call Python from Mojo. There's good Python interop support. And there on the description, I think Jack added some resources where you can choose which Python installation that you want to use. That way, if you're using conda environments and virtual environments, you can switch between them. And how to do that, there's also a blog post on the Modular blog where Jack wrote up a very nice blog post on how to switch between these environments. But there's a question on, I guess I'll paraphrase. Is there going to be a performance difference calling Python from Mojo versus just calling Python?
Yeah, so I believe someone actually measured this in like effectively putting the same Python code in Mojo, and it's sometimes faster, sometimes slower. And this leads into a whole discussion on like, what does compiling Python mean? And the short answer here is that many projects have tried to compile Python to make it faster, and they've either failed or they've taken shortcuts. And so they haven't actually built a proper compiled Python. They've built like a subset of Python. And so not everything is going to work. In Mojo, we're not trying to build a compiled Python. The approach that we're taking is, in a compiled language, you have things like types, you have things like pointers and memory. And using this, you can make Python programs faster through like progressive typing and stuff like that. So just compiling Python with Mojo could be faster, or it could also be slower. It depends.
Awesome.
The point is, like, you can use Python where it's great at, and you can use Mojo where it's great at. And Mojo allows you to combine the best of both worlds. As Jeff said, like, it's super, super hard to compile a dynamic language. It's, you end up with this, like, I can support 80% very easily, and then the last 10% is hard, and then there's like a 1-2% that's impossible. So that's something that we're not trying to even approach that problem. We're just giving you the ability to intermix your Python code with Mojo code, so you can essentially use the best of both worlds. You're getting the performance of Mojo, but you're getting the ecosystem of Python.
Awesome. Before we move on from the memory topic, I'm just curious, Aiden, you built this project from scratch, right? Llama.mojo. Clearly, you used a ton of different features in Mojo. Any hurdles or challenges or benefits you saw as you were implementing these, either with memory management or using different data structures? Anything you that stood out that you'd like to share?
Well, first thing I remember is that when I checked, Mojo didn't have the files input-output subsystem, so I was not able even read file. And then I found
Do
out
that now, right?
Yeah,
Correct
it
me if I'm
already
wrong,
has,
Abdullah.
and already, yeah.
Okay.
I have a pull request. I need to review it, and some folks, thanks them, added this feature like natively now. So, but before I had to use the libc external calls. The other thing is the worth mentioning is that the vectorization. So vectorization, it was really easy to implement. So I was like literally just changed few lines of code, and immediately it started working much faster, because now it leveraged the SIMD, etc., etc. For comparison, for you guys, just to understand, the Llama 2C till now don't have the native implementation of vectorization, because it seems that it's a bit complicated to implement it in a way that the code will not be mess up, but I found out that the Llama 2C aggressively vectorizing where it's possible, the GCC compiler doing this vectorization. So that's why the comparison Mojo versus Llama 2C is quite fair. So
it's sort of, are you explicitly doing this in your code by using those intrinsics or those, libraries, or is a compiler doing it for you? In Mojo, you actually have control over how do you do this, where you can choose not to do it, and where you choose to do it, right? Awesome. Okay, so let's see if there are a couple of more questions. I do have a demo that I'd like to show on these topics, and
one thing I want to mention, because Aiden mentioned it, is if you have feature requests that you need to do that. I mean, obviously Aiden is super smart and he figured out how to do file IO using fopen and fread and all that sort of stuff. But we're also like, you should file issues on GitHub, and we'll definitely take a deep look and implement these things if a lot of people are requesting. The Mac was a highly requested thing, so we worked very hard to release that. And file IO was also like an important thing as well that we
actually I have one feature.
Awesome. This is feature request live and
exactly. So thanks that Mojo now support the file IO, right? But we still can't know the size of file beforehand. So we should load the full content of file into the memory. Then we can check its buffer size. I would
file a feature request, and we'll add it in the next release. So
cool.
Isn't that cool, folks? I guess if you have feature request, highly encourage you to go to GitHub and do it. But you can also ask.
Yeah, or you can join Livestream.
Yeah. No, in all seriousness, right? One of the best ways to prioritize is your request, right? I mean, Mac OS support was exactly that. Like, it had the most, if you sorted by number of upvotes, it was the most requested feature on GitHub, and even standard library features or language features. We highly encourage you to go file requests, and it'll give us an opportunity to evaluate and implement those, right? So that's pretty cool. Jeff has been pretty active answering questions on the chat too. I think there are a couple of questions on I don't know if you want to summarize, Jeff, like a couple of questions about pointers and is in out a pointer and how to think about pointers in Mojo. Do you want to summarize some of the responses you gave on the live stream? Yeah.
So references in Mojo are not always pointers underneath, and this is really important for performance. Because in C++, for example, passing an int by const reference is very bad for performance because you're passing it in as a pointer and then loading it, whereas an int just fits nicely into a register. In Mojo, we have this decorator called @registerPassable that you can put on your types, and it will make the type faster if it is done correctly, meaning the type is hopefully small. And this means that in a lot of cases, you don't end up with pointers, you don't end up with the variable pinned to the stack. And this is one of the reasons why Mojo can get better performance than a language like C++ if used correctly.
Awesome. Okay. All right. So again, feel free to keep posting in your question on your on the live stream. Should we take one before we jump on? Yeah, here's the question.
Can I add something actually?
Yeah, go ahead, Elliot.
So I know a lot of people in probably the stream and even myself before even creating the tutorial, a lot of this was like really scary at first. Looking through the website, I was pretty much a Python JavaScript developer. Like I didn't really know much. And so what I really encourage you guys to do is go into the Discord. There's a lot of brilliant people there on the stream as well, and just ask questions. If you don't have if it's not answered, ask questions. If it is answered, you can always just search it up in the Discord. There's a way where you can essentially just search through a bunch of questions. It's in the top right-hand corner.
Jack pretty much lives on Discord. It's his second home.
Yeah, Jack is super smart too. So ask him. And then another point I want to get across that really helped me out when people aren't able to ask questions right away, or when it's hard to find answers that make sense to you, is to use the Kappa AI in their server. So I believe it's a large language model fine-tuned on a bunch of Mojo docs. Is that correct?
Yeah, it's fine-tuned on the Mojo docs and like GitHub and everything. So it comes out with some pretty surprising answers sometimes.
Yeah, exactly. So if you're if you're lost like me, trying to figure this stuff out, go in and ask the Kappa AI, and everything will hopefully make sense. Ask it to explain it to me like I'm a fifth grader. I do that stuff too, because sometimes we think like a fifth grader. So totally not a problem at all if something doesn't make sense. Just totally ask questions. Look at the GitHub. There's tons of resources. Everyone's happy to help. So.
Yeah.
Just someone just said in the chat, like it's not good enough. So it does have some limitations. Like it's not going to be able to answer everything. So there's a question section where you can ask any questions, and we'll be able to answer them from there. And the community helps out a lot as well. They answer a lot of questions too.
Yeah, I think you can get a ton of human help along with AI help, right? I think these models they're good to maybe just steer you a little bit in the right direction, but ultimately you can't really trust what they have. But there's tons of folks on Discord, including Abdul and Jeff and a lot of others in the company hang out in Discord. I think we are like super invested in trying to help you be successful in whatever you're building. Okay, so I want to do a quick demo and keep asking questions. We'll come back and the whole point of these demos is to give you an opportunity to see something that you want to learn more and ask questions and provide feedback and those sorts of things. So talking about Mac support, right? So I have my Visual Studio Code running here on the Mac. A couple of things I want to highlight is that there is a Mojo language extension. Highly encourage you install this, install Visual Studio and the Mojo language extension. It's really cool. You get a ton of like these code completions and hover help and all of that. It's really cool to make you productive using Mojo, and highly encourage using this. Of course, feel free to use whichever code IDE that you choose. The nice thing about Visual Studio is not only can you develop scripts, but it has this Jupyter Notebook integration, which is what I'm using here. It's nice for demonstration purposes, like what I'm going to do now. So I want to show you something interesting here. First, let me go ahead and run this. So Mac hardware, right? You have, like any other CPU, you have your number of cores that you see, but it also has dedicated vector units for vectorization, and we spoke about this briefly. I'll talk about what those are in a little more detail, and Abdul and Jeff can add more color. So the if you let's say if you go to EC2 or rent a machine in the cloud, you'll see number of cores, and you'll also see things like AVX 512 extensions and all that. So those are basically dedicated silicon to do vectorized math, so you can compute on multiple data in simultaneously. So in this specific Mac, I have an M2 Pro. So if I print the SIMD bit width, it says 128, and the width is 4 for single precision, which is float 32. What that essentially means is, let's say I have a matrix that looks like this. I can not only do we have multiple cores on this machine. I think there are 12 cores, out of which 8 are high performance cores and 4 high efficiency cores. So not only can you run an operation like in parallel using multiple cores, but you can also, oh, I see my screen annotations are not showing up. Okay. Not only can you run these, let's say you want to sum up all these values in a single array, and you want to generate a number. You can do this in parallel, right? You can do this across different rows in parallel. But with vectorization, you can also simultaneously compute on multiple values at the same time. So you're taking better advantage of the available hardware. That is what vectorization is. So think of, at a high level, think of if you're using NumPy, when you want to multiply or add two vectors, you don't do it element by element, you just add them. But under the hood, you actually do them in chunks. And this is what Aiden was mentioning with his project, and also the MatMul example, we do that. Now let's take a much larger tensor here, which is 10,000 rows and 100,000 columns. So essentially, if that is the data you have, and I want to sum up those 100,000 rows, it's a reduction operation. So I get a single vector which is 1,000 by 1. Now there are a couple of ways to do this, right? The naive way to do this is just to loop through all the rows, which is your outer loop, and loop through all the elements, which is your inner loop, and add them. So this is a naive way to do this. Now you can vectorize this, by which I mean you can do this simultaneously. If you go back to our example here, if you do a reduce add, you can do it on these four elements at a time. So it does this rather than loop through four, you do it at the same time. So you do a reduce add on this, a reduce add on this, and a reduce add on this, and so on, right? So you get a speed up there, and you can do that using the vectorize command here. So you specify a function, and you use SIMD load, which is a type that is in Mojo where you can load those 4 elements at a time, and you can compute a reduction, a reduce add. So just by doing this, you get some speed up. Now vectorization is one way to get speed up. The other way to get speed up is parallelization. So parallelization is a little more obvious, right? We have multiple cores. So let's say we do this on one thread and this on one thread, separate threads, right, which run on separate cores, and this and this. So the essentially, I mean, naively thinking, you can get 1 2 3 4 5, theoretically like 5x speed up, right, because each core will handle that separately. And with vectorization, if you do 4 things at a time, then you get 4x speed up, right? So parallelization and vectorization are both so parallelize, you can do parallelization without vectorization, which is what I have here. And finally, you can combine those two. So in this case, I parallelize, I vectorize and parallelize, which means not only am I doing a vectorized row-wise, but also reduction in parallel. And let's take a look at some of the results here. So I'll go run all these examples. So I see that if I only parallelize and not vectorize, which means I take advantage of multiple cores, I see about like 7x speed up. I have 8 high efficiency cores, so to say, on this Mac, high performance cores, and vectorization gives me about 10x speed up in this case. there's a little more nuance to why it is. You see here, probably Abdul or Jeff can add more color to here. There are ports on your CPU where you can send the SIMD width elements for it to process simultaneously. So I have 2 times SIMD width, which is single instruction multiple data for vectorization. And when I do them together, vectorize and parallelize, I see a much higher speed up. So from the naive element by element reduction, with parallelization and vectorization and doing together, you get this pretty substantial speed up, right? And all I wanted to share was the fact that you can take better advantage of your hardware on Mac if you're writing these algorithms because of the nice high-level APIs that we offer, where you can vectorize, parallelize, and speed up your implementations, if you will. So I will pause here. I know I did this at a pretty high level. I'm not a deep expert in these areas, and if Abdul or Jeff want to share more color to what's happening behind the scenes, I will leave the discussion open to them, and we'll also answer some questions along the way.
One thing I would mention is that 50x is compared to a base Mojo implementation. It's not compared to a Python implementation, right? So
100%,
going from Python to Mojo, you get huge speed ups, and then we're accumulating that 50x on top of that.
Yeah. I think that's something we showed in our. Hold on, am I sharing my screen yet? No. Yeah, so that's something we showed in our launch blog post. If you take a look, the MacMul example that Jack said, right? We have you get about 90,000 times speed up. That's what pure Python, like not using any libraries, right? Even if you use NumPy, under the hood, NumPy is like Python layer on top, but C++ routines, they actually take advantage of some of the vectorization routine in those lower level primitives, if you will, for the CPU. But in Mojo, like you can write this code. It's not complicated. It's not advanced that you have to learn those low level, multi-language sort of setups. You can do this in Mojo yourself. And the speed up I showed was starting from pure Mojo. Everything's pure Mojo, right? Mojo element by element, Mojo parallelize, Mojo vectorize, and combining them together. And I'm sure there are other optimizations that you can do that I am not fully well versed with, and these are stuff that Abdul does every day, speeding up some of our implementations that you'll see in our standard library. So yeah, that's sort of a quick demo, and yeah, you should try this out with your own examples. Awesome. Let's see if there are any questions. Yeah, I guess vector is only 10x, but depends on the hardware you run. That's really true. For example, I guess all Macs have more different CPU cores depending on if you're on Max or a Pro, but the vector unit should be the same. I don't know. I don't think.
Yeah. So the Macs you can do, in the best case, you can get 4x kind of from vectorization. But as you go to like Intel CPUs and so on, you can get, this is for floating point, but you get up to 8x or 16x, theoretical speed up. So it is hardware dependent, but sometimes it's a sacrifice. What these CPU vendors need to do is sacrifice or balance energy, density, how many cores am I going to fit in, simplicity, and so on. So it's just different trade-offs that are made at different, desktops will have probably bigger SIMD cores than, a tablet and laptops and so on.
Yeah, I mean on Intel, if you see on, I don't know, EC2 or somewhere, they'll mention ABX 512. I think that's half the information that you need to know because that's the vector unit. But then there are different number of ports that will allow you to get twice the speed up or like 4 times. It depends on the point is, yes, it depends on the hardware. On Mac, at least in this example, I did 2 times. And the API is simple, right? I didn't need to write extra code. I just said 2 times the SIMD width. And that's really the cool, fun, exciting thing, at least for me as a systems programmer as a sort of a Python programmer background. Awesome. So let's see if there are any other questions. Will we have to implement SIMD functions every time we have shortcuts? We have shortcuts in the standard library. Did I understand this?
The standard library has all like the math, for example, functions operate on vector elements. So in fact, this is an approach that we did in Mojo. So we said SIMD is the type, and it can be parameterized on a width. And scalars is a special case, like an int 64 is a special case of a SIMD value, but where the width is 1. Right? So actually, scalars are SIMD values, but again, they're width of 1, but the compiler will generate float 32. It's not going to create a vector of 1 element. But that also means that in the future we can generalize to like 2-dimensional SIMD vectors and so on, which are common. But all what Shashank is showing, all these functions, like if you go to like cosine or mod or whatever, they're taking SIMD values.
Yeah, that was a pretty cool thing that I discovered, which is all these standard library stuff are already like optimized on the SIMD types, right? But if you're using these more higher level data structures like tensors and whatnot, you can load SIMD elements and operate on them simultaneously using these math. So it makes it super easy for you to extend these foundational capabilities on your applications and higher level implementation that you may want to do for your applications, right? So all these you will see have a signature that's like load SIMD, operate on SIMD, return a SIMD, and in which case your responsibility is to load elements of that. Like in the tensor example, I say SIMD load, and then operate on that using one of the standard library functions. Awesome. So someone's asking the question, what is that magic 2 number? Why 2, not 3? I suppose the question is referring to the number we saw in Vectorize, and I think I briefly mentioned this. Again, I'm not an expert on CPU, but there are ports that's determined by a number of ports and the width of the port. I think that is what determines how many of these SIMD width you can process simultaneously. That's the extent of the knowledge I have on that. I don't know if anyone else wants to add more color to that.
Yeah, so I mean, it depends on the architecture, but sometimes some processors allow you to do 2 floating point operations per cycle, and that's like what the 2 is. On that system, 2 is the best value. So there's another question is like, how do I make that code portable? Like maybe it's 3 on some on some hardware and 1 on another and 7 on a third one. And that's one of the features in Mojo is you can auto tune. You can say, I don't know what it is, but computer, figure it out. Here's a benchmark function, run it on my data set and figure out what's the best number and just compile for that best number. So that's like a feature that kind of utilizes the computers where they're good at, and then it kind of makes you concentrate on the algorithm rather than which magic number should I choose.
And we actually have an implementation. So this is the documentation for AutoTune, and I think if you head over to like the Mojo examples repository, there are a couple of examples here, and if you take a look at the matml, is that the mat one? I think we have an implementation of these in some of these examples. So I think we do it in the matml notebook, if I'm not mistaken. But all of these have implementations in either the notebook or the scripts that is a good learning resources. Yeah, there it is. I think this is what you're referring to, right, Abdul?
Yes,
this is part of it. Yeah, so it's easy for you to like copy paste and get started. I mean, as I mentioned, I am not a systems programmer person, but it was fairly easy to get started with these things. Okay. Any other questions on the stream that we'd like to answer? Where are we at time? Oh, we are at time actually. Okay. I think this is good. It's good because we had a lot of questions and we answered them. A lot of good demos. We'll wrap up here before we do like goodbyes and thank yous. Any last topic anyone wants to share? Let's go. I guess round robin. Abdul, Jeff, did you want to share anything else? I know we want to share some changelog stuff. I'm happy to pull that up if you want to share anything briefly.
I was going to say kind of what Aiden was saying. One of the big features is file I/O, but another huge feature is we have a much more flexibility in terms of specifying keywords at arguments or parameters, and specifying default keywords that would make your API development a lot cleaner and more similar to Python. And there is a ton of features that are coming down the pike, and you should definitely download Mojo and try it. I know Jeff has a demo about parameters, and he can show that very quickly.
Okay, we could do a quick demo, Jeff.
Yeah, let's do it.
Okay, let's do it. I know people are excited. People want to see it. So go ahead.
So I saw someone in chat just mention traits. No traits yet. We're working on it. I know we've been working on it for a while, but we're actually working on it now. So this is a upcoming feature. The name that we've come up for it is auto parameterization. And the gist of it is like, okay, so you have a type like buffer, right? And buffer only has 2 input parameters, so it's not too terrible. But like if you had a type that had 5 or 6 of them, right? Typing them all in the function signature is not as nice. So what you can write now is you can write add, and you just have it take a buffer. And the buffer is actually normally supposed, this is the same as writing like add, dtype, size. I think the size or dtype come first. Well, one of them comes first. It's the same as writing this, so it's a little bit less verbose. And the best part is that if you want to, create a buffer, right? Say aligned. You can just call this function, and it infers the parameters for you. So that's all nice. But also what you can do now is you can refer to the parameters of another argument inside the argument signature. So you can do like type and size. I'll zoom in a bit here. So for example, we can just fill this with zeros. Write a basic for loop. I think is it. We need traits, obviously. So hopefully this works.
I think size comes first.
Oh, it does? Damn. It's the opposite of SIMD. There you go. Well, it adds 1 to 0, which is not super interesting. But so this hopefully makes the function signatures for parametric functions a bit less verbose. Yeah, that's about it. That's the demo.
And
so the code will look cleaner, right? That's the takeaway.
Yep. And this is an upcoming feature, so you heard it here first.
Don't try it. Yeah. And don't try it on the 0.4 version that you have access to today. Okay, thank you. I'm glad we squeezed that in. I think that's pretty cool. You got some good compliments about your typing speed, Jeff.
Oh, thank you. I type for a living, so doing it fast is pretty important.
All right. All right. Okay. I think we covered all the topics we wanted to. We went a little over. We apologize for that. But you were all such good um, what do you say, attendees. And we went through some cool demos, and also some we had guests today, Elliot and Aiden. So thank you for joining us, Elliot and Aiden. If you want to share anything before we close, we'll start with you, Aiden.
Well, what can I say? Thank you again, everyone, for joining us, and thank you inviting me. It's really great pleasure to attend this live session. It's my first time experience on YouTube, I think, but I hope I shared something useful for community, and I'm encouraging everyone to check out what's latest stuff going on with the Mojo, and try to contribute, even if you having some little idea. Contribute, send pull request, join our Discord, and like we can help everyone.
Thank you for that call out, Aiden. No, deeply appreciate you joining us. We're so happy to have you here, and also for creating these awesome projects. I think people enjoy them. 1.3K stars. That's pretty
Very
impressive.
impressive.
Really impressive for like a pretty young language, right? I mean, young language, also young release. We only released a month ago, and Aiden was able to put together in a week, I think. That's pretty impressive.
You haven't started though, Shashank. What's going on there?
Sorry?
You haven't started yourself.
I haven't started. Yeah, I know. I'm slacking. I know. I was just waiting for the auto parameterization, because code look cooler once that's released.
Okay.
Excuses. All right, Elliot. Any final words you want to share before we close out?
Yeah. So just a few like really quick things I want to run by. I'm not going to ask any more questions. I'll probably just ask those in the Discord. But so some things I wanted to cover were like some of my motivations for creating the course, my wish list, like what should be next in what I think should be next in Mojo would be really cool. What does transitioning look like? What is the learning curve? And just some feedback from people who have gone through the course. So to start off, motivations. Well, obviously, if you're in this if you're in this live stream, you probably think AI is changing the world and already has, and you're just all about that sort of space, like just make AI better. A lot of which use code bases that are extremely massive, because you have to port everything from like experimental Python to C or C++, and that's just code bases have gotten really big. So providing an easier time for Python developers to switch to these performance increases will definitely allow smaller parties, so like, for example, AI startups, to innovate more quicker, effectively giving all of humanity new ideas quicker and accelerating our ability to understand how to experiment and deploy these large beneficial AI systems. Things on my wish list. Well, I mean, these are kind of a far stretch, but maybe a modular specific IDE, and then maybe just allowing users to directly use, like, just say Mojo main.py and just have it run like boom, 10x speed up right off the start. That would be, of course, something that everyone would love. But of course, it's still an early language. Some of these things might be implemented later on. But yeah, so that was kind of my hopes, maybe. And in terms of transitioning, so if you've gone through my course, you're probably a beginner as well to Mojo, or you were. And so I actually came from Python initially. And so I just wanted to talk about what my experience was going over the language and sort of building up the skills needed to like do some of the mediocre programming in Mojo. So coming from Python, it was a bit of a learning curve, but honestly, being able to conceptualize the features and having an awareness of what is abstractly going on under the hood is really essential. And it's not too bad if you use the help of some of the engineers in the server, using GPTs to explain it for you. Expect it to be a learning curve. Obviously, it's closer to systems programming. It's going to be more challenging than Python. So as long as you're able to conceptualize those things quickly and you sort of get in a sort of a flow state of doing that, it's totally worth it, and it'll be a breeze for you. So it's honestly totally worth it, being able to scale things in a language that's much easier to understand as compared to something like C. And then in terms of feedback from students that I've gotten just in the comment section, so far so good. Some people have complained about a bad mic quality, but that's, you know, I'm not super rich. I can't get by these $1,000 microphones, so you're going to have to just bear with me. But some people also wanted some advanced content too. And I felt like maybe we should just get a tutorial out first so that people can just sort of dive right in head first and just give people the fundamentals, understand how to learn the language, not just gaining the skills for the language and teaching that, but also knowing how to learn the language and learning programming in general, I think is really important. And once you get those fundamentals, you can essentially just do anything. And yeah, that's pretty much all I got. So
that was very nice, Elliot, and very honest, and I think keeping it grounded, right? I mean, it's not going to be a breeze, no matter what people say. You still go through the learning curve. You have to still go through the hard work. You have to still spend efforts on. Thankfully, the resources and people to help. And again, you're getting a lot of shout outs in the comments on to do more courses. So awesome. All right, and that's it. I think I know we went over. I apologize, and that's, you all have good questions and we had good content to share with you. So thank you. We'll wrap up here, and we'll try to get to some of these in the upcoming live stream. So feel free to join us, and if you want to be notified, follow us on our social media channels also. Subscribe on YouTube so you'll be notified when we schedule our next upcoming live stream. And with that, we will close. Everyone wave. Thanks again. See you at the next one. Bye.
Bye.